The theory on field effect transistors (FETs) was developed much earlier than our understanding of BJTs. First patent on FETs dates from 1925. Julius Edgar Lilienfeld, an Austro-Hungarian physicist. The first FET was not invented until 1959. Integrated circuits, ICs, are chips, pieces of semiconductor material that contain all of the transistors, resistors, and capacitors necessary to create a digital circuit or system. The first ICs were fabricated using JBJTs in 1958. Robert Noyes of Fairchild Semiconductors fabricated the first CICs in 1959. SSI small-scale integration, 1 to 20 transistors. MSI medium-scale integration, 20-100s. LSI large-scale integration, 100-1000+. VLSI very large-scale integration, more than 1000. Black small square ULSI ultra-large-scale integration. Black small square WSI wafer-scale integration. Black small square SoC system on a chip. Black small square 3D ICs multiple layers of transistors fabricated horizontally and or vertically on a chip. O circuits containing more than 1 billion transistors on a chip are commercially available. Microchip. ULSI technology was conceived during the late 1980s when superior computer processor microchips, specifically for the Intel 8086 series, were under development. Wafer scale integration, WSI for short, is a rarely used system of building very large integrated circuit networks that use an entire silicon wafer to produce a single, super chip. Combining large size and reduced packaging, WSI was expected to lead to dramatically reduced costs for some systems, notably massively parallel supercomputers. The name is taken from the term very large scale integration, the current state of the art when WSI was being. SoC, a system on a chip or system on chip (SoC), is an integrated circuit, also known as an IC, or chip that integrates all components of a computer or other electronic systems. SoCs are commonly applied in the area of embedded systems. Logic families are sets of chips that may implement different logical functions but use the same type of transistors and voltage levels for logical levels and for the power supplies. TTL, transistor-transistor logic. BJTs are used. Introduced commercially in 1963 and still in production, though phasing out. High energy consumption, but relatively insensitive to electrostatic discharge, ESD. ECL, emitter-coupled logic. BJTs are used. Invented in 1956. High energy consumption, but can be designed for extremely high speeds. CMOS, complementary metal oxide semiconductor. FETs are used. Invented in 1963. First large volume application is in 1974. Considerably lower energy consumption than TTL and ECL, which has made portable electronics possible. BIMOS or BICMOS. Combination of BJTs and FETs in the same circuit. Methodologies which are based on system-level abstractions (VS). Device. Scalable designs. Full custom. Semi-custom (STD cell). Gate array. EPLA, EPLD FPGA. Specifications. Day by day the technology is increasing and customer also expecting new features, like low power consumption, high speed, in the device. In this stage the features information which is expecting from the customer is collected by some marketing people. Architecture design. The architecture team will design an architecture based on the specifications. The architecture is like a block diagram. We can find all the details which are using in the design, like processors, memories, and how the air connected. This architecture team will estimate the block area, how much power is required and cost for the design. RTL design, register transfer level, RTL, constructing a digital design using combinational and sequential circuit in hardware description language like Verilog or VHDL. The above architecture is converted into Verilog or VHDL code. This code describes how data is transformed as it is passed from register to register. RTL verification. It is a functional verification of RTL design. After the RTL design, by applying test cases, we verify the design and verification stage. If any mistakes are found, then the design is resent to the RTL designing department. The verification stage will take nearly 60% of the total time. Performing this verification at this stage is most advantageous because correcting the faults at routing stage is difficult and takes more time. Synthesis. It is a process of converting the RTL code into gate-level netlist. Up to RTL verification, the design is technology independent. In synthesis process, the design is converted into technology dependent. IT is three-stage process. 1. Translation. The RTL code is converted into Boolean expression. 2. Optimization. In this stage, Boolean expression is optimized by SOP and POS optimization method. 3. Mapping. In this technology-independent Boolean expression is converted into technology-dependent and generates the gate-level net list. The inputs for synthesis are RTL code, SDCN, lib. After the synthesis, the DFT, design for testability. DFT is a technique which facilitates a design to become testable after production. In this stage, we put extra logic along with the design logic during implementation process, which helps post-production process. The DFT will make the testing easy at post-production process. At this stage, an ATPG, automatic test pattern generator, file will generated. Floor plan. The floor plan is the process of determining the macro placement, power grid generation and I/O placement. It is the process of placing blocks macros in the chip core area, thereby determining routing areas between them. It determines the size of the die and creates wire tracks for placement of standard cells. It creates power straps and specifies PG connection. It also determines the I/O pin pad placement information. Placement is the process of automatically assigning correct position to standard cells on the chip with no overlapping. By global placement, outside of standard cells will placed inside roughly. By the detailed placement, the standard cells will place in site rows. Legalize placement. In placement stage, we check the congestion value by GRC map. CTS clock tree synthesis. In this stage, we built the clock tree by using inverters and buffers. In the chip, clock signal is essential to the flip-flops. To give the clock signal from clock source, we built the clock tree. It is the process of balancing the clock skew and minimizing insertion delay in order to meet timing and power. Routing. Before the routing stage, the connection between the macros, standard cells, clock, I/O port are logical connections. In this stage, we connect all the cells physically with the metal straps. Routing is divided as two parts. 1. Global routing. 2. Detailed routing. The global routing will tell for which signal which metal layer is used. Before the detailed routing, all are the logical connections. In detailed routing, the physical connections are done. Sign-off. After the routing, the physical layout of chip is completed. In sign-off stage, all the tests are done to check the quality and performance of the layout before tape-out. After this, the design is converted into GDS2 file. Fabrication. By the GDS2 file information, we fabricate the chip. The total design is converted into chip by the manufacturing process. Packaging and testing. After the fabrication process, we test the chip. If there is any fault in the design, then we modifies the design by repeating the steps. If there are no faults,